welcome to this video session. My name is Samuel Chukwuemeka. In this video session, we shall add and subtract unlike fractions. And this is the first part of the video session. Please watch out for the second part as well. Now, before you view this video, please make sure you have completed the videos on adding and subtracting like fractions. You have to know how to add and subtract the like fractions first before you add and subtract the unlike fractions. So if you have not viewed the videos on like fractions, please do that first. Okay? Now, adding and subtracting unlike fractions entails that what we want to do is to make the two unlike fractions to have the same denominator. In other words, to make them to be like fractions. Then we will add or subtract as the question says. So if you recall in the previous video, unlike fractions are fractions that do not have the same denominator. So they do not have the same denominator. If you look at all these fractions here, they do not have the same denominator. So what we want to do is to make sure that those two different denominators, if we can bring both of them to be the same denominator, then we can now add or subtract. Okay? Why can we not do it directly? We cannot do it directly because of this, Recall, in the previous video, we talked about a land that is divided into 4 plots, right? So let's say that this is 3. Let's say that this is 3 out of 4 plots. And then in this case now, let's now have like 6. Okay, so and let's say that this is 1 out of 6. So this is like saying 3 out of 4 minus 1 out of 6. You see, because this is the whole here is 4, the whole here is 6. We cannot add them or subtract them directly. We cannot do that because they do not have the same denominator. Now, if they had the same denominator, if this was 1 out of 4, then we can easily say 3 minus 1. And, okay, 3 take away 1, leaving us 2 out of 4, which is now 1 out of 2. But because they are not the same, we cannot. So what we have to do is to bring them to be the same. So what we have to do is to bring them to be the same denominator. Then we can now apply that. So in summary, for you to add or subtract unlike fractions means that you have to make them to be like fractions before you now add or subtract. That is the main thing. Now, the next question is this. How do you make unlike fractions to be like fractions? How do you now get these two different denominators to be the same? So what we now have to do is that we now have to study the concept of common denominator. Okay? So we want to get the two denominators to be the same, to have a common denominator. Common means same. Okay? We want to make them to have a common denominator. Now, because we have several common denominators, right? Like if you look at 6 and 15, one of the common denominators there is 30. Okay, if you look at common denominators of maybe 6 and 15, okay, here we see that 15 is the denominator, 6 is the denominator. How do we get all of them to have a common denominator? Okay, you can start by this. 6 and 15, a common denominator is 30, because 6 can divide 30, 15 is also a factor of 30. 30 is a multiple of 6 And 30 is also a multiple of 15. Another one is what? 60. 60 is also a common denominator. 90 is also a common denominator. 120 and the rest of them. So you ask me now, how did you get this? How are you getting this? Right? And then of all these common denominators, which one do we actually need to use? That's a good question. Now, of all the common denominators, it does not matter. You can use any one. But because we want simplicity, we want to simplify, we want to work with less number, simple numbers. Okay? We don't have to work with large numbers and then later we keep simplifying. No, that is not what we want. We want to use the least common denominator. That is what we want. For these common denominators, we want to use the least common denominator. Now, this goes back to what is the least common denominator. You look at now, what are the multiples? Multiples of 6. Multiples of 15. So multiples of 6, you have 6. 6 times 1 is 6. 6 times 2, you have 12. 6 times 3, you have 18. 6 times 4, 24. 6 times 5, 30. 6 times 6, 36. And the rest of them, okay? 6 times 7, 42. And so on and so forth. Now, multiples of 15. 15 times 1, you have 15. 15 times 2, you have 30. 15 times 3, you have 45. 15 times 4, you have 60. So, you look now, what is the least common multiple? Now, what are the common multiples? You see that the common multiples, we see that the common multiples of 6 and 15, you have this 30, okay? So the common denominators means common multiples. That is what it means, okay? Now, in some countries, they refer to it as LCM rather than LCD, least common multiple, rather than least common denominator. Yeah, they mean the same thing, right? Okay. So another multiple is 60. Okay, 6 times 8 is 48. 6 times 9 is 54. 6 times 10 is 60. 60 is another common multiple. 60, 60. And if you keep listing, you will find other common multiples. Now, we now see that of all these common multiples, it is easier for us to work with the least one. And that least one gives us 30. Okay, this, you now tell me, hey, Mr. C, this is a very big method. This is a Herculean task of finding least common multiple, or the least common denominator. This is a Herculean task. Does it mean that I have to keep on listing all these multiples? You know, I keep on listing all the multiples. Do I keep on listing them? No, there is a shorter way of finding it. So we now come here. Let's come over here. We look at a 6. Okay. Now 6. Let us find the prime Let us find the prime factorization of 6, which means let us find those factors of 6 that are prime numbers. And let's start with 2. 2 is a factor of 6. 2 into 6 remains what? 3. So 6 is 2 times 3. Okay? 15. 2 cannot divide 15. So the next prime number is 3. You start with the smallest prime numbers. Now, 1 is not a prime number, so you take it out. 2 cannot divide 15, so you discard 2. 3. Now, 3 into 15, 3 divided 15 is what? 5. So, when you now want to find the least common multiple, okay? We want to find the least common multiple. Least common multiple, or least common denominator. You look at each one, but if a number appears twice, you count it 1. You count all the multiples of each one, Okay, let me write this of 6 and 15. You count all the multiples of each one, but if there's a number that appears twice, count it as 1. So 2 will come 2 times. Now 3 and 3 appear 2 times. If you have a number that appeared twice, count it as 1. So 3 and 3, you take only a single 3, times 5. So this will be 2 times 3 is what? 6. 6 times 5 is what? 30. That tells you that 30 is the least common multiple. Now, you can even count 3 again. If you count 3 twice, then that is not going to give you the least common multiple. It will still give you a common multiple, but it's not going to be the least common multiple. Of course, if you counted this 3 twice, that would be 30 times 3, which is 90. Yeah, it's going to give you a common multiple, but not the least. When we are talking about the least common multiple, we want if we want to take all the numbers that appeared, then if a number appeared on both of them, okay, in this case we say twice because we're dealing with 2 numbers. Okay, if it's 3 numbers, if it appears in 3 of them, right? So if a number appeared in both of them, you count it 1 time. Yeah, and that gives you the least common multiple. Instead of doing it this way. Okay? So now let's recall what we just said. When you have an unlike fraction, that tells you it has unlike denominators. Okay? It doesn't have a common denominator. The first thing to do is to make it a like fraction, which means get the 2 different denominators and make them to have a common denominator. Not just a common denominator, but make them to have the least common denominator, because we want to work with the simplest denominator, the simplest common denominator. That simplest common denominator is the least common denominator. Okay? Now, for you to make the unlike fractions to be like fraction, that is to have the least common denominator, that tells you that you have to now find the least common denominator. And how do you find the least common denominator? You can do it this way. You can find the prime factorization of those 2 denominators. Okay? Of those 2 multiples. You find the prime factorization. This is one way to do it. Another way that you might be familiar with is this. You have 6. 6 is 2 and 3. And then you have 15. 15 is 3 and 5. And then you count 2. LCM will now be 2 times. You count 2. Then, because 3 appeared twice, take it 1 time times 5. And that will give you 30. Yeah. Because it appeared. But you make sure that you find the prime factorization of those multiples. Finding the prime factorization of those multiples means that make all the factors to be prime numbers. Okay, 2 is a prime number, 3 is a prime number, 5 is a prime number. Okay? Alright, so unlike fractions converted to like fractions. How? By finding the least common denominator of the denominators. And how do you find the least common denominator of the denominator? Finding the prime factorization of those denominators. Okay, you find the prime factorization of the denominators. It gives you the least common denominator. Then you find, using the least common denominator, you can now convert these unlike fractions to like fractions. Okay? So let's do number 1. 2 out of 15 plus 5 out of 6. So the least common denominator we have here, we have 30. LCD is 30. That does not mean that if we use 60, we won't get the answer. No. We shall still get the answer. In fact, let us do it with 30, and then the next thing, let's do it with 60. You will see and you will kind of see the difference why we want to use 30. So we now express this to have a denominator of 30, this to have a denominator of 30, to be like fractions. Then you ask yourself, what will you do to 15 to give you 30? You multiply by 2. So you put times 2 here. And whatever you do to the denominator, you have to do it to the numerator. You also put times 2 here. So this is 4. 4 out of 30. Now, this is what we call an equivalent fraction. That is another vocabulary word. Another vocabulary word we will use here. Another vocabulary word. In addition to the one we used initially. Equivalent fractions. Equivalent fractions. What does equivalent fraction mean? When you simplify those fractions, it still gives you the same answer. It still gives you the same fraction. Example, if I say 1 over 2, or whether I say 2 over 4, or whether I say 3 over 6, or whether I say 4 over 8, or whether I say 5 over 10, they are all equivalent fractions, all of them. Or whether I say 16 over 32, because I multiply 1 by 16, it gives me 16. I multiply 2 by 16, it gives me 32. They are all equivalent fractions. So, 4 out of 30 is an equivalent fraction of 2 out of 15. Because you ask yourself, what will you do to 15 to give you 30? You multiply by 2. And then, for you to have an equivalent fraction, whatever you do to the denominator, you still have to do to the numerator. If we have to multiply the denominator by 2, then we also have to multiply the numerator by 2. So this gives you 4 out of 30. And you see, it's still the same thing, but it now has a different denominator. Okay, you ask yourself again, what will you do to 6 to give you 30? You multiply by what? 5. Okay? And whatever you do to the denominator, you also have to do to the numerator. What is the equivalent fraction of 5 out of 6? Provided that you have that fraction to have a denominator of 30. So that would be what? 25 out of 30. So now, as you can see, they are now like fractions. So our aim was to convert the unlike fractions to like fractions. And we have achieved it by finding the equivalent fractions. Okay? Equivalent fractions that have the same, fractions with the same denominator. Equivalent fractions are fractions that when you simplify them, it gives you the main fraction. Okay? It's still the main fraction. They are all equivalent fractions. So we want to make the unlike fraction which we've made to a like fraction. Okay? And then we found the LCD first. Then we found an equivalent fraction of the original. So we've made the unlike fractions to be like fractions. So here we can now add. Okay? So this will now be 4 plus 25 out of 30. And that will give us 29 out of 30. That becomes our answer for that. All right? Okay, let's do the next one. Let's do number 2. We have 5 out of 12 minus 1 out of 15. Okay, first of all, let's find the LCD of 12 and 15. That is what let's use here to find the LCD. You know what? Let's use this space just for LCD or LCM. So we have 12. 12 is 2 times 2 into 12 is 6. Now simplify 6 again because 6 is not a prime number. 2 can still go. 2 into 6 is what? 3. So this is 2 times 2, 4. 4 times 3, 12. Then the next one is 15. 2 is a prime number, but 2 is not a factor of 15. The next prime number is 3. 3 into 15 is 5. 5 is a prime number. So what's the LCD here? The LCD will be the only thing is that we will count all the numbers, we will multiply all the numbers, all the prime numbers, but if we have the same prime number appearing 2 times, we count it 1 time. So this will be 2 times 2 times 3 times 5, right? 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So instead of you to have the multiple, you do the multiplication table of 12 and 15, 12 times 1, 12, 12 times 2, 24, 12 times 3, 36. Instead of you to keep listing the multiplication table of 12 and the multiplication table of 15 and then finding the least common multiple, it is better you do it this way. It saves you time. Okay? So now, let's go ahead and do question 2. And this gives us now 5 out of 12 minus 1 out of 15. So the least common denominator we found was 60 here. We found it 60. So you see we have put it to have the least common denominator. Then the next thing is find an equivalent fraction. Okay? So what will you multiply by 12 to give you 60? 5. Whatever you do to the denominator, you do to the numerator. So 5 times 5 is what? 25. So the equivalent fraction of 5 out of 12 is 25 out of 60. Then what will you do to 15 to give you 60? You multiply by 4. Whatever you do to the denominator, you also do to the numerator. So this is 4 out of 60. Right? So what you now do is you can now subtract 25 out of 60 minus 4 out of 60. And this is 25 minus 4 over 60. And that will give us 21 over 60. Now you can still simplify this. What is the GCF? What is the greatest common factor of 21 and 60? We see that it's 3. 3 into 21 will give us 7. 3 into 60 will give us 20. So our answer becomes 7 out of 20. Okay? Alright, now let's do the mixed numbers. So let me go ahead and erase this. Okay, for the mixed numbers, question 3, we can still do it 2 ways. Those 2 ways that we talked about, we can still do it like that. The 2 ways that we used in our previous video, with mixed numbers, we can do that here. Okay? Now, but let's go ahead and find the LCD of 4 and 5, because they are the denominators. So 4 will be 2 times 2, and then 5 will be just 5. Okay? Because 5 is a prime number already. So the LCD will be 2 times 2 times 5, because there's nothing common. So you take all the numbers. So 2 times 2 is 4, 4 times 5 is 20. So LCD is 20. So what we want to do now is, we can use the first method. We can use the first method, method 1. Okay? 4 plus 5 will give us 9. Right? And then we add the integers, and then we add the fractions. 3 out of 4 plus 1 out of 5. So LCD here is 20 over 20. 4 times 5 will give you 20, and 3 times 5 is 15. Here 5 times 4 will give you 20. 1 times 4 is 4. So you add them. So this is what? 15 plus 4 over 20, which is 19 over 20. So when you now add 9 plus 19 over 20, gives you 9 whole number, 19 over 20. Now, this is one way to do that. One way to do it. Another way, method 2, second method. or method 2, like we did in the previous video. Let's convert. We can convert this. 3 out of 4. 4 times 4 is what? 16 plus 3 is 19 out of 4. Then 5, 1 over 5. 5 times 5 is 25. 25 plus 1 is 26 over 5. So we have 19 out of 4 plus 26 over 5. Okay? LCD is still 20, 20. Right? So 4 times 5, because what will you do to 4 to give you 20? You multiply by 5. So 19 times 5 is 95. Then 5, what will you do to 5 to give you 20? You multiply by 4. Then 26 times 4, because whatever you do to the denominator, you do to the numerator in order to get the equivalent fraction. Now 4 times 6 is 24. 4 carry 2. 4 times 2 is 8 plus 2, 10. So we have 95 over 20 plus 104 over 20. So let's kind of finish it here. We now have 95 over 20 plus 104 over 20. And this is 95 plus 104 over 20, which will give us 4 plus 5 is 9, 10 plus 9, 19. 199 over 20. Okay? So we have to convert this improper fraction to a mixed number. So let's go ahead and divide 20, divide 199. Of course, 200 will give us 10. 20 times 10 is 200. So 10 will not work. So let's go back and use the closest one to 10. And that gives us 9. 9 times 20 is 180. 199 minus 180 is 19. So this will give us 9 whole number, 19 out of 20. Which is the same answer we got here. Okay? Alright, let's go ahead and do question 4. Let's do question 4. Just the same way we did in the previous video for mixed numbers, we can still do that here. Alright. Question 4 can be rearranged. We can rearrange question 4 to be 7, 1 out of 5 minus 3, 3 out of 4. We can rearrange it to look like that. Okay? So, we still have 5 and 4, so we still got 20. We still got to keep our 20. Okay, so we do 7 minus 3. We do the integers first, method 1. Gives us 4. And then 1 out of 5. 1 out of 5 minus 3 out of 4. So LCD here is 20. 20. This is 5 times 4. So this will be 1 times 4. So this will be 4 out of 20. Here this is 4 times 5. 3 times 5. Which will be 15 out of 20. Now, I want you to listen well. In this case, we now have 4 out of 20 minus 15 out of 20, which is 4 minus 15 out of 20, which is negative 11 out of 20. And that's a problem. There's a problem here. Because we can have negative 11 out of 20. We cannot have it, no. We cannot have that negative there. And we still have 4 as an integer here. We cannot have negative 11 over 20 here, while we still have 4 as an integer here. So what do we do? What we're going to do now is, we take 1 from this 4. We take 1 from this 4. Okay? So what do we do now? What we're going to do now is, we can take 1 from this 7, because this is a problem here. There's a problem here. So what do? we take 1 from this 7, add it to 1 out of 5. That's what we will do. So when we take 1 from this 7, we take 1 and add it to 1 out of 5. So that will give us what? 5 out of 5 plus 1 out of 5, and that is 6 out of 5. So this will now be 6 over 5. So this is what this will be. Because we don't want to have negative. That's why we're doing this. We don't want at all. There's no way we have to have negative. We cannot. So we now do this all over again. So this will now be 6 minus 3 will give you 3. And then 1 over 5. Now we now have 6 over 5 minus 3 over 4. So of course we have out of 20 here. Out of 20 is 5 times 4. So this will be 6 times 4, which is 24. This is 4 times 5, 3 times 5, which is 15. So we can now have 24 over 20 minus 15 over 20. And that will give us 24 minus 15 over 20. And that will give us 14 minus 5 is what? 9 over 20. Okay? So we now have our answer to be what? 3 plus. So what's our answer now? Our answer will be 3 plus 9 over 20, which is what? 3 whole number 9 over 20. So this will be our answer here. 3 whole number 9 over 20. Okay, now, if you want to avoid this issue, you can just use the method 2 in this kind of question. Okay, with method 2, let's go ahead and use method 2. This will be 7, 1 out of 5. So this is 5 times 7 is 35 plus 1, 36 over 5. Then 3 out of 4. 4 times 3 is 12 plus 3 is 15. 15 out of 4. So we have 36 over 5 minus 15 over 4. This is over 20. This is over 20. So this is 5 times 4. This is 36 times 4. So 4 times 6 is 24. Carry 2. 4 times 3 is 12 plus 2. 14. 4 times 5 is 20. So 15 times 5. 5 times 15 is what? 75. 75. Okay? So we now have 144. 144 minus 75 all over 20. Which is 14 minus 5 is what? 9. 13 minus 7. 14 minus 5 is 9. 13 minus 7 is 6. 69 over 20. And that will give us a 3 whole number 9 over 20. So any of these two ways will work. Any of it will work. Okay? But just know that when you're using the first way, the first method, if you subtract the fractions, when you subtracted the integers and you got a positive integer, when you subtract the fractions and get a negative fraction, then that's a problem. So you go back to that integer, you carry 1 from it, add it to that fraction, and you can still have this, and then you subtract. That's the way we do it. Okay? So let's do the next one. 5. Question 5. Now for question 5, let's find the LCD of 5, 7, and 10. Okay? So here we have 3 fractions. We have 3 fractions here. So this is 5 is 5, 7 is 7 because both of them are prime numbers, right? Then 10 will be 2 times 5. Okay? So what will be the LCD? LCD, we have, let's start with the smallest one, okay, 2 times. Now, 5 appeared twice. It appeared twice, so you still count it one time. You count it one time. And then 7 appeared once. Okay? So this will be 2 times 5 is what? 10. 10 times 7 is 70. Right? So if 5 appeared twice, still count it as 1. If 5 appeared the 3 times, like I mentioned earlier, count it as 1 as well. Okay? So 70. Okay, so we now have, let's now express it, the equivalent fraction, 2k over 5 minus k over 7 plus 7k over 10. So this is over 70, over 70, over 70. So 5 times what? 5 times 14 will give you 70. 2k times 14 will give you 28k. Okay? 7 times 10 will give you 70. K times 10 will give you 10k. 10 times 7 will give you 70. 7k times 7 will give you 49k. So 28 minus 10 is 18. That's 28k minus 10k is 18k. 18k plus 49k will give us what? 49, 18. Right? This is 7. And this is what? 6. 67k. So this is 67k over 70. Let's finish it. If we finish it, we have 28k minus 10k plus 49k over 70. So this will give us what? That will give us what? 18k plus 49k over 70. And that will give us what? 67k over 70. That becomes our answer. That's the way we do it. Okay. Question 6 and 7. We will still do it like we did for like fractions. We will solve and we check. Solve and check. So let's solve it and then we check our work. J minus 9, J minus 1 over 9 equal to 7 over 12. Okay, so we move this constant to that. J will be 7 over 12 plus 1 over 9. Now, 7 out of 12 plus 1 out of 9. Let's find the LCD of 12 and 9. So we get back here. Let's find the LCD of 12 and 9. 12 will be 2. 2 into 12 is 6. 6 is not a prime number. Break it down again. 2 into 6 is 2, then 3. Then 9 will be 3 times 3. So the LCD will be 2 times 2 times 3 times 3. Because this 3 and 3, call it one time. And then you still find this other 3. Okay? So this will be 2 times 2 is 4. 4 times 3, 12. 12 times 2 times 2, 4. 4 times 3, 12. 12 times 3 is 36. Okay? 2 times 2, 4. 4 times 3, 12. 12 times 3 is 36. Yeah. So LCD is 30, the LCD is 36. Okay? Now we come over here. This is 36. 36. 12 times 3 is 36. 7 times 3 is 21. 9 times 4 is 36. 1 times 4 is 4. Okay, that's the equivalent fractions. So this will be 21 plus 4 This will be 21 plus 4 over 36. And that will give us what? 25 over 36. Okay, check. When we check, we write the main problem. We write the main problem. J minus 1 over 9 equal to 7 over 12. Left hand side, right hand side. Left hand side is what? J minus 1 over 9. Right hand side is 7 over 12. Yeah. Sometimes, most times when you do math, it's good to look at it 2 times, you know. To look at it 2 times to make sure that everything is correct. Now, our J was what? 25 over 36 minus 1 over 9. Now, what is the LCD of 36 and 9? If you do that, you will see that it's 36. Honestly, if you do that, you will see it's 36. So this is 25 over 36 minus, if you have over 36 here, this will be 4 over 9. And this will be 21 over 36. And you can, 3 can divide. 3 into 21 is 7. 3 into 36 is 12. Now, but for the sake of, you know, let me do that. 25 over 36 minus 1 over 9. LCD of 36 and 9. 36 will be 2 into 36 is 18. 2 into 18 again is 9. 3 into 9 is 3. Okay, 2 times 2, 4. 4 times 2, 12. 12 times 3, 36. These are the prime factorization. This is the prime factorization of 36. The next one is 9. 9 is what? 3 and 3. So 3 and 3 are called 2 times, we count it as 1. 3 and 3 are called 2 times, we count it as 1. LCD will be 2 times 2 times 3 times 3. And that gives us 36. So this is over 36, over 36. What will you do to 36 to give you 36? Multiply by 1. Multiply by 1 also to the numerator. This is 25. Here multiply by 4. Multiply by 4. 4 over 36. That is why we had 25 minus 4. 21 over 36. You simplify it further, you have 7 out of 12. Okay? Now, last but not the least, 11 over 12 equal to G plus minus 3 over 16. So we simplify this, you know, we make these 2 signs equal to be 1 sign. Now this should be negative is there. It does not matter whether the negative is outside or inside. It really doesn't matter. Does not. Yeah. Those 2 signs that are equal, that are the same, that are close to each other. Whenever you have 2 signs close to each other, like I demonstrated in the previous video on like fractions, make those 2 signs 1 sign. If they are close to each other, make them 1 sign. Using the rule that I used. Okay? So this is 11 over 12 equal to G minus 3 out of 16. So rearrange this. This will be G minus 3 out of 16 is equal to 11 out of 12. So G will be 11 out of 12 plus 3 out of 16. Now, let's find the LCD of 12 and 16. Okay? What will be the LCD of 12 and 16? 12 will be 2 times 6, then 6 is 2 times 3. 16 will be 2 times 8. 8 will be 2 times 4. 4 will be 2 times 2. So 2, 4, 8, 16. Okay? So the LCD will be, these 2 appear 2 times, call it 1 time, times, these 2, call it 1 time, times 3 times 2 times 2. 2 times 2, 4. 4 times 3, 12. 12 times 2, 24. 24 times 2, 48. 48. So we have that 11 over 12 plus 3 over 16. LCD is 48 over 48. 12 times 4 is 48, so 11 times 4 will be 44. 16 times 3 will be 48, so 3 times 3 will be 9. So 44 plus 9 out of 48 will give us 9 plus 4 is 13, 53 over 48. And what will it give us? One whole number, 5 out of 48. Okay? One whole number, 5 out of 48. That becomes our answer. Okay, let's check. When we check, what is the first thing we do when we check? We write our what? The original equation. 11 over 12 equal to G plus minus 3 over 16. Then we write our left-hand side and our right-hand side. Our left-hand side is 11 out of 12. Our right-hand side is G plus negative 3 over 16. So our G is what? 5 over 48. Then minus 3 over 16. And this gives us what? 53 out of 48 minus 3 out of 16. So let's find the LCD of 48 and 16. LCD of 48 and 16. What does it give us? So this is 48 will be 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. 2, 4, 8, 16 times 3, 48. Then 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So the LCD, of course, you know what the LCD will be. The LCD will be 48. I mean, 2, 2, we count it one time, times. 2, 2, we count it one time. 2, 2 again, one time, times. 2, 2, one time, times 3. And that is 48. LCD, 48. So, we now have 53 over 48 minus 3 over 16. LCD here is 48. 48. 48 times 1 is 48. 53 times 1 is 53. 16 times 3 is 48. 3 times 3 is 9. So this is 53 minus 9 over 48, which is 13 minus 9. 13 minus 9 is 4. 44 over 48. And what can go? What's the GCF of 44 and 48? The greatest common factor is 4. 44 divided by 4, whatever you do to the numerator, you also do to the denominator. That gives you 11 out of 12. So you have 11 out of 12 on your right, 11 out of 12 on your left. You are good. Okay? Thank you so much for listening to this video. Please watch out for part 2.